So here we are, we're going to talk about section 2E, unions and intersections. So we've got our sets, A and B, and our universal set. But we're going to get into that example in a minute. We're going to talk about what a union is first. So A, union B, represents all elements of both sets. Okay? And then we have what's called an intersection. And we write it like this. A intersects B. And that's elements in both sets, elements of both sets only. So we'll explain a bit more as we go through this. So basically, we'll just get into the example. So we have elements of both sets, elements of both sets only. So union means we get all of them. Intersection means only the ones that are in both. So this question says, list the elements of sets A and B. So in set A, we'll write it like this. What are the elements in set A, Katie? Positive integers less than or equal to 12, but we want them to be prime.
3.
Yep, 3. Is it the first one? What about 2?
2, yeah.
2. 4.
Yeah. No.
5.
Yeah.
6. Nope. He's shaking his head. 7?
7, yes.
8.
8. No.
9.
No.
10.
No.
11.
Yes.
Okay. So those are all the elements of set A. Now B is all factors of 12. So we know we have 1 times 12. So those are both going to be factors. What else do we have? 2 times...
2 times 6. 3 times 4.
That's it. So there we have all the factors of 12 and all the primes of numbers less than or equal to 12. So then we have to draw our Venn diagram. U represents the universal set. We've got circle A, circle B. So do we have anything that goes in this middle part? This part. Which stuff is in both sets?
2.
Is that it?
3.
3. So then we write all the other ones in the rest. So in B, we're going to have 1,
4, 6.
6, and 12.
12 is considered in it. Okay, and
Okay.
5, 7, 11.
So there's our Venn. What numbers are missing? 9 isn't in either A or B. What else?
8.
Okay. 10.
Okay.
All right. So that answers show sets A, B, and the union or the universal set on a Venn diagram. Now we have to list the elements in A prime. So what goes in A prime? A prime is a complementary set, so it's everything that's not in A.
Everything that's not in A?
Yeah. From 1 to 12.
1 to 12. 1.
Yeah. We got 2.
4. 6. 8. 9. 10. 12.
Okay? So now we want to know everything in the intersection. A intersects B. So what that means is we want to know all the elements that are in both A and B. What's that going to be? They have to be in both.
Oh, the numbers that are going to be in both? Like A and B? 2 and 3.
Yep.
I wasn't looking at that. I was looking at that.
So that part right there is A intersect B. So those are the elements that are in both A and B. Then we want to know A union B. A union B. Well, that's all the elements in both of those sets combined. So we've got 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 8, 9, 10 are not in there. So we get 11.
12.
12. So everything in the circles
Should you count 2 and 3 since they're in there?
I did count them because they are part of it, but I don't count them twice.
Yeah.
All right. So we get A union B. Now we have to find the number of elements. Ooh, I'm going to leave this up just in case we need it. The number of elements in A intersect B.
Would you be able to erase that?
I could,
More room?
but we have room right here.
Yeah.
How many elements are in both in A intersect B? Ready?
2 and 3.
So how many numbers is that?
2.
That was a hard one. Now the number of elements in A union B.
10. Oh, 9.
9. I hope you guys are all getting this at home. Now, the number of elements in the complement of B. Now, the complement of B is everything that's not in B. So if we know 1 to 12, there are 12 numbers, or we can just look up here and go, okay, what's not in B? How many?
3. 6.
So the number of elements that are in the complement of B is 6. Now, and let's see. That's it. That's all there is to that example. There is another example, and actually, you know what? We'll throw it on this video because it won't take long. They do mention something called mutually exclusive sets or disjoint sets. And all that means, it's not the example I'm going to do. When I draw mutually exclusive sets, I draw my Venn a little different because if you know what a cassette looks like, which some of you do and some don't, mutually exclusive means there's no intersection. There's nothing in set A that's in set B. So they're totally separate. So, kind of another way to look at it is this would be A. No, not necessarily, but A and A prime would be complementary.
But if you go to 12, they both have 6 numbers in it, technically, if you didn't.
Or they could be out here too.
Yeah.
Right.
But basically,
Yep.
if you did it, they're even or off. That's not going to
Yeah.
happen, but.
That could be it. You're so right. Now, we're going to talk about Venn diagrams, and we shade the region representing certain things. Now, it says A and B, but not both. But not both. So what they want us to do, draw a Venn. We got A, we got B, A, B, U. And I'll draw the other question. A prime intersect B. So, A and B, but not both. So it's in A, it's in B, but it's not in here. So what we do is we shade all of this out here, because that's all of A. And this is B. And we're shading everything in A and B, but the overlap. Okay? So, that's it. That's all you got to do for these. Pretty basic. Now, A prime intersecting with B. A prime, I'm going to do this two ways, is like this. Everything outside of A is A prime. And
so
then
A
we
is all
have...
the numbers that aren't.
And what's
aren't
B?
prime. B is some of the numbers that are prime.
Maybe. I mean, these are not... We're looking at different things now. So this represents B, right? That circle?
Yeah.
This is everything that's not in A. So what we consider is the intersection of A, the purple, and the black, which gives us this. So I get the cross pattern to tell me that is the intersection of the complement of A with B. So basically, it's everything in B except what's in A. And there's a few practice questions on how to sketch these, and there
But
might even be one on
things that are in A and B are shaded in too. Oh, they're not supposed to be?
Nope.
Because they're still in A.
Right. And we want them in, not in A, but in B. Does that make sense?
Yeah.